Hello everyone, welcome to the new video in this series, and today we are going to explore Anycast and split TCP as we decided in the Azure Front Door first video, right? And we must know the concept of Anycast or split TCP, how exactly it works, how exactly it enhances the Azure Front Door, because these are the features which makes Azure Front Door a front door so that it can be used for the different applications, right? So let's get started. In order to understand this is a pretty generic diagram that we have created so that we could grasp the concept and then we can apply the knowledge wherever is needed. So these are three regions, R1, R2, R3, are different regions, and all the regions are connected with Microsoft Backbone Network, right? And these are the edge locations, pop locations, meet me locations. All those are connected with the Microsoft Backbone. We have understood this concept in our first video where front door will let the traffic go with the edge location to the backend server or the origin. Let's suppose, hey, this is our VM or any compute service which is hosting the applications. We call it in the terms of front door as origin. Origin. Okay, all these are origin. And it is a global load balancer. So it's load balancing between multiple regions. So we have the origins or the backend servers in different regions. Now, the idea is to understand Anycast and split TCP to the core. So, who is accessing? Somebody sitting outside is accessing. That is our user via internet, of course, right? And internet is risky, right? So that's the reason. Red internet user, and we must put some DNS, public DNS here so that we can understand the flow, entire flow. All right. So our topic is Anycast. If we have to define Anycast, Anycast is networking technique where a single PIP right here, single IP address or public IP address is assigned to multiple locations. So the same PIP, let us call it 01. The same PIP assigned to the edge locations 01, right? Same PIP is there. PIP 01, PIP 01 in all edge location. That's why the magic happens. And it is across the globe in all the edge location in different regions across the globe. So when a user makes a request to this IP address, the internet routing system ensures that their request is sent to the nearest best performing location which hosting that PIP. Okay, so how exactly this nearest location identified? Because front door uses Anycast to efficiently route traffic to its globally distributed edge location, ensuring fast, reliable, and optimized content delivery. So let's see how Anycast works in Azure Front Door. So user request, let's call it abc.com. abc.com. So user is browsing this website. When user enters abc.com in the browser, the request is first sent to public DNS, right? Public DNS server. The DNS resolution happens and it returns the Anycast public IP or CNAME that maps to it, which is assigned by the Azure Front Door. Now, DNS resolves to an Anycast IP. So, which means Front Door advertise its same Anycast public IP across multiple edge locations worldwide, right? That we have already talked about at the beginning of this video. So this goes to DNS. DNS throws back the IP address. IP address already been assigned to multiple edge locations. Now the user request is automatically routed to the nearest edge location. Okay, let's suppose this is the nearest edge location. So how exactly it is getting routed to the nearest edge location? Well, or point of presence, right? It is on the basis of latency, it is on the basis of congestion and the availability, right? All these things will decide which is the closest edge location for the user. All locations has the same PIP through Anycast, and Front Door will let the user know where is the nearest edge location for them. Now the chosen edge server receives the request and checks it has uh, content locally. Why locally? Because it also has a facility of caching. If it has the cached content available or caching enabled, it will send the data or information from here, which means reducing load on the backend. If it in caching, which means reducing load on backend server or origin, right? This is what it is. Let me put it here so that it would be clear. Caching here, backend server here, origin, right? If the content is cached, the response is served directly from the edge location. And if the content isn't cached or if caching isn't enabled, the request is forwarded to the best backend or origin server. Now, how this forward request happens? Through split TCP. Yes. So request come here, request goes, split TCP. That we will understand in the same video. Anyways, let's continue with this. If the chosen edge server, let's suppose this is the chosen edge server and this is down. Okay, this is unavailable. The Anycast routing mechanism automatically redirects the request to the next closest edge location. Okay, next closest healthy edge location, let's call it. So this functionality ensures what? Can you guess? Well, high availability and reliability. Okay, this is there in Front Door. Now, the edge server then forwards the request to the backend origin server using optimized network path. What does that mean? Azure Front Door continuously monitors the backend health and load to ensure requests are sent to the best performance instance, right? Whichever is closer to the user, best performing instance. Now, once the backend process the request, the response is sent back to the Azure Front Door Edge server. The Edge server then delivers the response to the user through the shortest and fastest possible route. Okay. Now, when this edge server sends the request to the origin server, it goes through MS backbone. So by default, it is very fast, right? So we got the Anycast demystified. Now let's see why Anycast makes front door better. Let's understand few things here, or rather, I should write here. The very first thing is since the request is routed to the nearest edge location, okay, and the round trip time is significantly reduced. This means that users experience faster load times and lower network congestion, right? How this round trip time is significantly reduced because otherwise the user will go whole to here over the internet and come back. But in this case, user is only going to the edge location, then the MS backbone network traffic. If second user comes and caching is enabled, it will only go to this pop, right? So improved performance. We could say improved performance, or rather low latency, which is improved performance. If one edge location fails, the request is automatically redirected to the next best healthy available edge, ensuring site remains accessible, right? And traditional and unicast IPs do not have this ability. Once an IP is unreachable, users experience downtime, but not any cast. So high availability, and we could say automatic failover, which is high availability, right? Now, any cars distribute traffic across multiple locations without requiring complex load balancer or DNS level configuration. So, traffic is balanced dynamically based on real time network conditions. So, global load balancing. Anycast naturally helps mitigate DDoS attacks by dispersing malicious traffic across multiple locations by default, right? So multiple edge location, preventing overload on a single point. So we could say resilience against DDoS. Now, since the edge handles caching, and in the previous video we understood SSL termination and WAF policies, the origin server experience reduced load and better security. We can say reduced load for origin and better security for origin, right? Which is backend server, right? So let's conclude this. Anycast plays a critical role in Azure Front Door by ensuring fast, reliable, and secure global content delivery. By leveraging Anycast, Front Door can reduce website load times by routing users to the closest edge, ensure high availability with automatic failover, improve security by mitigating large-scale DDoS attacks, enhance backend performance by offloading SSL and caching at the edge. This is what makes front door superior to traditional load balancers and CDNs. All right, so this is all about Anycast. Now let's explore uh, split TCP. What are we going to explore? Split TCP. So split TCP is again a networking technique used to optimize long distance connection by breaking a single TCP connection into multiple segments. All right, and Azure Front Door leverages this technique to improve web application performance by reducing latency and accelerating traffic flow between user and backend servers. For example, if this is the backend server, uh, the approach will be like this directly. It will go to this guy, a huge connection, and this will be break into multiple segments here and here. Let's understood it in a better way. So let's try to grasp the flow. Okay. User request abc.com. Let's try to understand this with the same flow. When user types abc.com in a browser, this device queries public DNS. The public DNS resolves to CNAME or public IP, right? And front door operates on a global Anycast or with me. So this means that the same public IP address is available at multiple Azure edge locations. The user request is automatically routed to the nearest available front door edge location based on network latency, congestion, and availability, ensuring fastest response. Now, till now, all good as of now. Now it's time to use split TCP connection. Establish a split TCP connection to optimize the connection between user and the backend application because origin is our application. Origin is our application. All right. So the user's browser, right, abc.com, when it has the information of the TCP IP, establish a TCP connection. Okay, this establish a TCP connection. Let's suppose this, the closest edge. So TCP handshake with the nearest Azure front door. TCP handshake, but that's how the TCP works, with the nearest edge location instead of directly connected to the backend like this, right? So this drastically reduces the latency to the initial handshake since the edge location is geographically closer to the user as compared to the origin, very close, right? Now, the second TCP connection, this is the connection number one. This is con one. And the second connection is from edge server to backend application. This is our second connection. This is our application. Origin is our application. And this is our second connection, con 2. Right. So the front edge location establish a separate TCP connection with the backend server, which may be in Azure or another cloud or on premises. So since the edge server is part of Microsoft high-speed network backbone, as you can see, this will go from inside. I'm just showing you like this. It will go like this, right? All right, then, since the edge server is part of Microsoft high-speed network backbone, this connection is much faster and more stable than a direct long-distance connection. Now, if the selected edge location becomes unavailable or experience high latency, Azure Front Door dynamically route the request to the next best edge location. This automatic failover ensures availability and reliability without user intervention. Now, you understand? Instead of one single TCP handshake, it will go only to the edge, then Microsoft to connection, saves time and distance and faster load times. Why? The TCP handshake occurs closer to the user. So TCP handshake, faster load time. Okay, faster load time. Why? Because TCP handshake occurs closer to the user. Result, reduced latency, especially for users far from the backend server. Now, the second connection, edge to backend. Second connection happens over Microsoft internal backbone, which means improved performance, right? Because it is very fast and lower network congestion and improved application responsiveness because it is MS backbone. Now, if one edge is down, Azure Front Door automatically reroutes to the best healthy available edge, resulting high availability and seamless failover, which is already part of Anycast. The both things are involved in the same traffic flow. Anycast and split TCP. Don't think these are two different things. Like different process. The same user requesting ABC going to the origin, utilizing Anycast and split TCP. Okay, both are working together. All right, so it also optimized network throughput. If you like, how? Because large network distances are split into two multiple efficient connections, fewer drop packets, and more stable connections, of course. And of course, built-in security benefits. Why? Because traffic is encrypted between edge and backend, and Azure WAF that we see in the last video can inspect and filter malicious requests. So, how this all traffic flow is happening in TCP? Just to conclude the video, user enters abc.com, DNS resolves to front door anycast IP. User request is routed to the nearest edge location, right? And edge server then establish separate optimized connection to the backend application. If the chosen edge is unavailable, then front door dynamically selects another edge location. Traffic flows securely through the Microsoft backbone. So Azure Front Door with split TCP and Anycast ensures that applications are fast, resilient, and globally available while improving user experience and network efficiency. With this, let's end this video. I hope it was informative and you guys like it. Thank you for watching, and you